Hello Year 11, welcome to 17G, and we're talking about sums to products today. This is the last exercise of our trigonometry chapter and hence your last new exercise for Year 11 Extension Maths. So that's kind of exciting. So what we want to do today, it says here at the top of the page, we can rearrange the sums and difference identities that are written below there using A and B to find the product of trigonometric ratios. So these four formulas at the top of the page are the four of the compound formulas that we learnt earlier in this chapter, and I have numbered them 1, 2, 3, and 4. And we're going to do some really cool kind of simultaneous equations with these to make some new equations. So it says down here, by adding and subtracting these equations, it gives us the four products to sum formula that we need. So for the first formula, what I'm going to do is I'm going to add equation 1 and equation 2. So equation 1 is sine of A plus B, and equation 2 is, that I'm wanting to add to it, is sine of A minus B. Now when I add those two equations, let's just have a look. I'm adding these two things here together. I would have sine A cos B from the first equation, and I have another one of them in the second equation that I'm adding together. That's going to make 2 sine A cos B. And that's what this is equal to, 2 sine A cos B. There it is. Okay, now what about the other part of the equation? The cos A sine B, and then I have a minus cos A sine B. Those parts cancel out. So that is the first equation. It's one version of the first equation. On the formula sheet that you are given, it actually writes it in a slightly different way. It divides the 2 across to the other side, which would be sine A cos B equals half, open some square brackets, sine A plus B plus sine of A minus B. Okay, now that formula you probably think looks worse, and I would probably agree with you, but that is the one that they give you. So let's highlight that one as being important. Let's go on to the second one we want to find. What we're going to do is take the first two equations again, but this time we're going to subtract them. Let's see what happens. If I go sine of A plus B, that's the first equation, and I subtract sine of A minus B, the second equation, that would mean that the sine A cos B minus sine A cos B, those parts there would cancel out this time. Then for the second two terms, cos A sine B, when I subtract, I'll have two minuses next to each other. Minus minus makes a plus. Another cos A sine B, which will make 2 cos A sine B, which is the formula down here. Alright, so just like I did last time, I'll divide the 2 across, which will be cos A sine B equals half of sine A plus B minus sine of A minus B. Okay, it's formula number 2. The third one, cos A and 2 cos A cos B, we're going to get this from the third and fourth equation. If we add them, equation 3 plus equation 4. So that is cos A plus B plus cos of A minus B. So cos A plus B plus cos of A minus B. Now when we look at what that would do, if I have on the right hand side of those expansions, cos A cos B and another cos A cos B would add together to give me the 2 cos A cos B that I get. This second part over here, because one of them is a minus and one is a plus, they are going to cancel out. So it does work. Dividing the 2 away, we get cos A cos B is equal to half, big square bracket, cos of A plus B plus cos of A minus B, close brackets. Equation 3. And last one, you can probably guess that we're going to subtract the third and fourth equation, but we need to put equation 4 first so that the subtracting the minus signs go the right way. So that means equation 4 is going to be, get rid of those parts, equation 4 is cos of A minus B, and I want to subtract equation 3, which is cos of A plus B. Let's check to make sure it does actually give us what we want. When I subtract these parts, cos A cos B minus cos A cos B, they will disappear. And sine A sine B minus minus will make that part a plus. Sine A sine B will give me the 2 sine A sine B. So it works. Divide the 2 away. Sine A sine B equals half cos A minus B minus cos A plus B, and they are the 4 products to sums formulas that you will need. Now they're called products to sums, by the way, is because we have on the left-hand side of each of those formulas, we have 2 trig functions multiplied together. So sine A cos B, for example, 2 things multiplied together. And using the formula, it becomes 2 trig functions that are added or subtracted. If you look at the second formula, 2 trig functions that are added together. All right, let's have a look at the examples. Express each product as a sum or difference of the trigonometric functions. So we just want to practice using those formulas. So for the first one, we have got 2 cos 5x sine x. Okay, so we do have the 2 at the front, which means it'll probably be easier to use the top version of the formula. And it is cos then sine. So cos then sine is this formula here. 2 cos A sine B, that's the version that I want to use. That formula becomes, using the expanded side, sine of A plus B. Now the A is going to be the 5x and the B is going to be the x. So that will become sine of 5x plus x, then minus, using this formula up here, sine of 5a minus b, which is 5x minus x. We just want to collect those things up. 5x plus x is 6x, so it's sine 6x minus 5x minus x is 4x, so sine of 4x. And that's it. It's just practice using the formula at the moment. Part B, let's try again. We have 2 sine 4a sine a. So it's a 2 again, and sine sine. So 2 sine sine is this formula here. So it's going to become cos of a minus b minus cos of a plus b. So a is a bit confusing because a is 4a and b is a. Using the formula, that will become cos of 4a minus a, then minus cos of 4a plus a. Alright, that becomes 4a minus a is cos 3a, and 4a plus a becomes a 5a. Part C, cos 3 theta cos 5 theta. So it's a cos cos. There's no 2 there. Cos cos is the third one here, but we probably want to use the highlighted version this time because we don't have the 2 at the front. So that means my A is going to be the 3 theta, the B is going to be the 5 theta. However, let me start that again. It will make it easier because we need to subtract, because I know that I've got an A minus B here, that would be 3 theta minus 5 theta. And I would end up with a negative 2 theta. To avoid negative signs, it's easier if you always have the bigger angle first. So 5 theta first, and I'll put the cos 3 theta second. It just makes it easier to do because of that subtracting. So that means that I will use that A is the 5 theta and B is the 3 theta. It will work if you do it the other way, as long as you can deal with the negative angle that it makes. All right, so cos 3 theta, cos 5 theta, using this expansion, is going to become half A, cos of A plus B is going to be cos of 5 theta plus 3 theta. Then we have plus cos A minus B, which is 5 theta minus 3 theta. That's where you would have got the negative if we hadn't switched them around. Okay, that makes half cos 5 theta plus 3 theta is 8 theta, plus cos 5 theta minus 3 theta is 2 theta. Done. And D, we have got sine 3 theta, cos theta. So sine then cos means we're using the top one. We don't have the 2, so the highlighted version. So it's going to become A would be the 3 theta, B would be the theta. Half out the front, bracket, sine of A plus B, so that's sine of 3 theta plus theta, plus sine of A minus B, which is 3 theta minus theta. Okay, just tidying that up. 3 theta plus theta becomes a 4 theta, and 3 theta minus theta becomes 2 theta. The end. All right, so that was just practice using those formulas. On the next page, we have some questions that are a little bit more interesting. So question number 2, find the exact value of sine 75, sine 15. So you can see that there are 2 trig functions multiplied together. It's sine, sine, which means if we look at our formulas back here, sine, sine is going to be this last formula here that we need to use. Okay, without the 2 though, so the highlighted version. Okay, so that's going to become half of cos A minus B minus cos of A plus B. So let's have a look for this question. Sine 75, sine 15. If the 75 is the A and the 15 is the B, using that formula shown above, we have half, bracket, cos of 75 minus 15 minus cos of 75 plus 15. Okay, simplifying that, 75 minus 15 is 60, so cos 60, and 75 plus 15 is 90, so cos 90. They are both nice exact value of both values that I can find exact values for. So cos of 60 we get from our exact value triangle. So if I have 60, very much not to scale, sorry about that, 1, 2, and root 3. Cos of 60 would be adjacent over hypotenuse, which is a half. So I have the half at the front. Cos of 60 is a half, and then minus cos of 90. Now cos of 90, any multiple of 90, you can get an exact value on your calculator as long as it's in degrees, but you can also get it from the graph. The cos graph looks like that, roughly. Starts up here at 1, and at 90 degrees, it would be going through 0. So that cos of 90 is actually 0. You can check that on the calculator if you like. So half minus 0 is just half. and half times a half makes a quarter. So our answer for sine 75, sine 15 is a quarter. You could have, or you can type that into your calculator to check, if you like, that it works, but I do want to see all that lovely working out. And last question, question 3. I want to show that sine theta plus sine 3 theta plus sine 5 theta over cos theta plus cos 3 theta plus cos 5 theta is equal to tan 3 theta. Now it says show, but basically when I have something like this, I need to do this as a proof, which means I'm going to start with the left-hand side and show that I can get to the right-hand side. So the left-hand side is equal to sine theta plus sine 3 theta plus sine 5 theta over cos theta plus cos 3 theta plus cos 5 theta. Okay, now we know that this is going to involve our sums to products formulas, and to save us flicking backwards and forwards, I've written the 2 relevant formulas in red on the side of the page here. We know that we are trying to get to a tan 3 theta. We want it all to simplify down to that. So we don't really want to mess too much with the 3 thetas that we already have. Okay? So what we want to do is use the sine 5 theta and the sine theta, and same with cos, and use those sums to products formulas. So let's just look at the top for a minute. Sine of 5 theta and sine of theta. Can I think of a way to write those in terms of A and B, 2 things added and 2 things subtracted? To help me out, I'm going to write this again in order. The sine 5 theta first, then the sine theta, and the 3 theta that I know I want to leave for a moment. I'm just going to put that on the end. So same on the bottom with the coses. Okay, now these first 2 terms here, the sine 5 theta and the sine theta, let's have a look at those angles. 5 theta could be written as 3 theta plus 2 theta. It would be could be 2 things added together like that. It would also work that would be 3 theta minus 2 theta. That would make the second one sine theta. Okay, now recognizing that, I have got 2 sine things added together where I've got the A and the B added and the A and the B subtracted, and it would work for those 2 terms. So what I'm going to be doing over here on the right-hand side, my right-hand side formulas, here is sine A plus B and sine of A minus B. Okay, that is what I've got. I want to go from the right-hand side of that version of that formula back to the left-hand side. Now, for starters, that half, I'm going to have to times the 2 across. Okay, so that's going to give me 2. Now, the 5 theta, and so the sine 5 theta, sine theta, going backwards to go to the left is going to become sine A is the 3 theta, and B is the 2 theta, so cos of 2 theta. That's the formula. Just for those first 2 terms, I still have the sine 3 theta on the end. Okay, now I want to do a similar thing for the cos ones down the bottom. Cos of 5 theta and cos of theta. So I can use cos A plus B and cos of A minus B. There's my 2 coses added together, and I can go backwards through the formula back to this version. Okay, so that will become 2, because I multiply the 2 across again. Cos of A, which is still 3 theta, and cos of B, which is 2 theta. I still have the cos 3 theta sitting at the end. So, now that I have done that, on the top you will hopefully see that there is a sine 3 theta in both of those terms, and I can factorize that out. So that would be sine 3 theta out the front, open a bracket. There would be 2 cos 2 theta remaining from the first term and just a plus 1 from the second term. On the bottom, we have a cos 3 theta in both terms, so let's factorize that out. Cos 3 theta, open bracket. There would be 2 cos 2 theta left from the first term and a plus 1 for the second term. Now, if you look closely at those brackets, you can see that they are the same. 2 cos 2 theta plus 1 and 2 cos 2 theta plus 1. They will completely cancel out. And all that's left is sine 3 theta over cos 3 theta. Now, hopefully you remember that sine over cos is equal to tan. So because it's sine 3 theta over cos 3 theta, that would make a tan 3 theta, which is our right-hand side. Whew, what a good question, hey? All right, so that is it. You are finished. We've finished all the new work, so you need to finish exercise 17G and finish off this topic.